multiplication of two metrics. Multiplication of matrices. There are two ways we can do matrices multiplication: scalar product multiplication or multiplication of two matrices. Now we're doing multiplication of two matrices. Two matrices can be multiplied together only when the number of columns in one matrix is equal to the number of rows in the other matrix. A matrix A equal to Aij is equal to this matrix, and matrix B, which is Bi, is equal to a column matrix. And so we need to find out the row and column. This is 2 by 3, 2 rows, 3 columns, and this is 3 row, 1 column, 3 by 1. If the number of column is equal to the number of row of the two matrices, then multiplication is possible, and the product will be 2 by 1. So the first column and the second row, that means we can do multiplication. The final matrix will be 2 by 1. A matrix A and matrix Bi, which is column matrix, which is 2 by 3 and 3 by 1. A times, that dot means times in this case, A times B will be equal to A11 times B1 plus A12 times B2 plus A13 times B3. And then we do the second row. A21 times B1 plus A22 times B2 plus A23 times B3. And this matrix will be, when you add them together, you get 2 row, 1 column. Example 1. I've got these two matrices. This is 2 by 3, 2 row, 3 column, and we're timesing that by 3 row, 1 column, 3 by 1. From there to there is equal. The column is equal to row. Therefore, this is good for multiplication. And the final product will be 2 by 1. Okay, so let's perform this operation. 4 times 8 plus 7 times 5 plus 6 times 9. In this second row, 2 times 8 plus 3 times 5 plus 1 times 9. And then we need to sum them up. That would be 32 plus 35 plus 54, 16 plus 15 plus 9. Now we need to add them all up. So that would be 121 and 40. This is a 2 by 1 matrix, which is the product. Example 2. This is 2 by 4, 2 rows, 4 columns. And this is 4 rows, 1 column. The column is equal to the row, so that's good for multiplication. And the final product will be 2 by 1. So this is 2 times 3, 6, 3 times 4, that's 12, plus 5 times 2, that's 10, plus 1 times 9, that's 9. Then we do the second row. 4 times 3 is 12, plus 6 times 4, 24, plus 0 times 2, that's 0, plus 7 times 9, that's 63. Then we need to add them up and add them up. That equals to 37 and 99. This matrix is 2 row, 1 column. Example 3. We've got these two matrices. We need to check if we can multiply them before we multiply them. So first, this is 3 by 2 matrix. 1, 2, 3. 3 row. 1, 2, 2 columns. And this is 2 by 4 matrix. 2 and 2 are the same. That means it's good for multiplication. And the final product will be 3 by 4. Here are the two matrices. The 3 by 2 and 2 by 4. This matrix A times matrix B. Multiplying this matrix with that, we'd start with 1 times 8 plus 5 times 2. And then the second one will be 1 times 4 plus 5 times 5. That's 4 and 5. The next one will be 1 times 3 plus 5 times 8. The next one will be 1 times 1 plus 5 times 6. And then we do the same thing with this and that. So we get that, we do this, we do this, with that, we get this, and that, with this, we get that. And finally, we do 3 and 4 with this, that, this, and that. And this is what we get. Then we add them together. We get 18, 29, 43, 31, 30, 43, 62, 44, 32, 32, 41, and 27. And that's that final matrix. And this matrix is 3 by 4. As we expected 3 by 4 matrices. Squared matrices. It follows that a matrix can be squared only if the matrix is a square matrix. That is, the number of rows equals to the number of columns. M equals N. This is a square matrix because the number of rows equals to the number of columns. Here is matrix A, and we're going to square that matrix. And to square that matrix, we're going to write A squared equals to A times A, and that equals to matrix A times matrix A. This is 2 by 2 times 2 by 2. These two are equal, so that's good. And the final product will be 2 by 2. There'll be 4 times 4 plus 7 times 5. That's 35 and 16. Same thing, 4 times 7 plus 7 times 2. Then we do 5 times 4 plus 2 times 5. And then we do 5 times 7 plus 2 times 2. And then we add them all together. We get 51, 42, 30, 39. And that's a square matrix. Is matrices product commutative? A times B equals to B times A, or A times B does not equal to B times 8. That's what we meant by commutative. Commutative is indicating that the product of the factor is important here. Matrix A and matrix B, we need to find A dot B and B times A and see if commutative. Matrix A and matrix B. What does commutative means? It means A times B is equal to B times A. Non-commutative means A times B is not equal to B times A. Give an example. 4 times 6 equals 24. 6 times 4 also equals 24. Number multiplication is commutative. We need to find if matrix A and B are commutative. First, this is 2 by 3 and 3 by 2. We can multiply them. A times B will be equal to, well, we'll be doing the matrix, do 1 times 7, that's 7. 2 times 8, that's 16. 3 times 9, that's 27. The next one is 1 times 10, that's 10. 2 times 11, 22. 3 times 12, 36. Then we have to do the second row with this. We got 4 times 7, 28. 5 times 8, 40. 6 times 9, 54. 4 times 10, 40. 5 times 11, 55. 6 times 12, 72. Then we add them up, we get 50, 68, 122, 167. That's matrix A times B. Now we need to do matrix B times A. This is B, and that's A. 3 times 2, 3 by 2, 1, 2, 3, 3 rows, 1, 2, 2 column. This is 2 by 3, 1, 2, 2 rows, 1, 2, 3, 3 columns. We need to multiply them. So the first one is 7 times 1 plus 10 times 4. That's that one. 7 times 2 plus 10 times 5. 7 times 3 plus 10 times 6. 8 times 1 plus 11 times 4. 8 times 2 plus 11 times 5. 8 times 3 plus 11 times 6. Final one is 9 times 1 plus 12 times 4. 9 times 2 plus 12 times 5. 9 times 3 plus 12 times 6. We add them all up. We get 47, 64, 81, 52, 71, 90, 57, 78, 99. And that's matrix BA. Now we can see the A times B is not equal to B times A. Matrix multiplication is not commutative. Example exercise. Question 1. We need to find A times B matrix. So first of all, we do the matrix A and B. We need to find their order. That's 2 by 3. And this order is 2 by 3, which meant that that is not equal to that. Therefore, no matrix multiplication is possible. Question 2. We got two matrices. We need to find if A and B are commutative. This matrix is 3 by 2. This is 2 by 3. Yes, we can multiply them together. This is good for multiplication. And the expected product is 3 by 3 product. This is matrix A times B. And this is matrix B times A. 2 by 3 and 3 by 2. Again, this is possible. A times B, this is what you get. And B times A, this is what you get. Now, these two are different. This matrix is not commutative. The multiplication of the two matrices is not commutative.